Hi Sheng, this is your feedback video for the Circular Motion 2 homework. Start by looking at question 1. So first thing you need to do is label the forces acting on the car in the cars in figures 1 and 2. You've correctly labelled friction here, but there's no reaction force. You've missed this out. There must be a reaction force equal in magnitude to the weight, so that needs to be added in. In this diagram, you have drawn the reaction force, and you have correctly drawn friction. So you can get 1 mark for this. Just be careful, the reaction force, I think you've drawn the arrow so that it starts here, so it's quite long. I mean, it's not hugely important, but you should make it long enough such that the vertical component of that reaction force is the same magnitude as the weight here. Okay, but I'm not too bothered about that. Let's look at your next bit. The possible origins of the centripetal force on the car. There are 3 forces: weight, reaction, and friction. Good. We'd ignore weight because it's perpendicular to the... Yes, good. Yeah, this is perfect. Yeah, you get full marks for that. Nice. Good. This is correct. Well done. So far so good. Question 2. Okay, that's good. Good. This is pretty straightforward, this question. I'm pretty sure you'll get full marks. Yeah, nice work. Let's have a look at the question 3. So this is the van going over the humpback bridge. Interesting. So they've asked you to label the forces that act on the parcel as it goes over the highest point of the bridge. There's certainly, obviously, it has a weight, and there is a reaction force of the floor of the van acting on the parcel. So these 2 are correct. But this here is not right. There's no friction force acting on the parcel. At least according to the mark scheme, there is no friction force. Now, a few people have put friction. I'm going to go with what the mark scheme says, and I'm going to say that shouldn't be there, but we'll talk more about this in the lesson. I think I know why you've put that. We'll talk about it in the lesson. Okay. This next bit's correct. Now, that should be 55 newtons. To 2 sig fig, you should get 55 newtons. Now, I've got a feeling it might be because you've used 9.8 for G instead of 9.81. I'd like you to check this again using 9.81. You've got to use the data sheet value for G. Check it again and see if it rounds to 55 newtons, but at the moment I can't give you 2 marks. I can only give you 1. Let's have a look at this. If V becomes bigger, this term will get smaller. Yes, and when it is less than 0, there will be a negative normal reaction, which will never happen. The particle, yeah, the package, you mean, will no longer stay on the car but fly. Yeah, that's true. You haven't actually, Sheng, you haven't said explicitly anywhere what happens to R when V increases. You need to be clear and just say that when the speed of the van increases, the reaction force will decrease. Okay, so you could have made that a little bit clearer. I'll give you 2 marks for this, but I'm not going to give you 3. All right, so just this needs a little bit of fleshing out. Okay, state what happens to R, then you can do this stuff here where you explain that at this particular speed, R becomes 0. That's when the package loses contact with the floor of the van. Finally, good, yeah, all good. And then this bit here is quite hard. Let's just see how much you've written. Okay, yeah. Right, I'm just going to pause while I read through your answer. Okay, Sheng, this needs some work here, okay? We're going to go through this in the lesson, but I'll tell you what you've stated that's correct. You've said that it's moving in a circle, so it requires a centripetal force. Perhaps you could explain why does it moving in a circle, why does that mean it is accelerating? Explain why, even though the speed is constant, why is it accelerating? Explain that. Then you would say acceleration requires a resultant force. In this situation, that resultant force points towards the center of the circle. Okay, you can do that. Yeah, I can't really credit any marks though for this, unfortunately. This bit at the end here, the ball also experiences weight, so the vertical force is not balanced, it cannot be horizontal. I think I know what you mean. If the string was horizontal, there would be no upward force to balance the downward weight force. In fact, if we draw a kind of side view of the ball, let me just draw the string. There's the tension force acting on the ball, and there's the weight of the ball, mg. The reason that the string cannot be horizontal is because it's the vertical component of the tension force that balances the weight. So it has to be slightly slanted like this so that there is a vertical component to the tension. Okay, so that's why the string is never horizontal. All right, so we'll talk further in the lesson. So overall, very good. Maths is obviously excellent, but a couple of the sort of more wordy questions just need a bit of work. Okay, so if you have any questions, Jack, just let me know.